great to see you at RISC-V Summit Europe. Thank you so much.
Thank you. Great to see you.
Yeah. So you gave a talk earlier today on how Codasip is helping solve the RISC-V puzzle and optimizing performance at lower risk. Can you tell us a little bit about how Codasip is solving the puzzle?
Sure. So we do an EDA tool called Studio, and we use it to create RISC-V processors. And when you look at that process, actually the design is only about a third of the time and cost and engineering resources to create the design, and 2/3 of it is verifying the design, making sure that it works. So the brilliance of RISC-V, as you well know, is as an open ISA, you can customize it and change it. And historically, the way those customizations and changes needed you to re-verify again. So our brilliant engineers figured out a way to create bounded customization, including new instructions. So if you follow some basic rules and the tool will not let you make any mistakes, then you can add instructions that are fully verified and you don't have a problem. So it's absolutely fantastic, and it can turn a basic software engineer into a processor designer. It's brilliant.
Sounds like multiple careers at one time.
Yes, definitely.
So, talk more about verification. Why is that so important? We hear the promise of RISC-V and customization and hardware-software co-design, all these great things, but talk to me more about verification.
Well, it's a huge topic. And within verification, the basic problem you have is you're putting together things that have billions of switches, tens of billions, hundreds of billions of switches. And there's so many permutations and combinations that you really can't test them all. So, to make sure that you don't have bugs, you have to get it good enough, and then we can have a discussion about good enough. Now, for some certain areas, you can do what's called formal verification, which means it's a mathematical proof that this must be true. So that's the type of approach that we use in Custom Bounded to try to say, as long as you only change these, and it might be X and Y are positive real numbers, then it works. But if you do something different, it doesn't work. So it's this combination of heavily testing an infinite number of permutations and combinations, or mathematically proving it's correct. And so that's just the hardest bit for not just processors, but all of the SoCs that get done.
It sounds like the approach you're taking is both going to accelerate the verification process as well as make it more durable and strategically viable.
Yeah, and as I mentioned during the talk, and actually Thomas before me from Siemens EDA mentioned, part of the issue is there are just not a lot of processor designers and verification engineers. So there's just an absence of people to do this. And with RISC-V offering all of these opportunities, a golden age of architecture again, as Patterson described, that's really fantastic. But if you don't have a lot of verification engineers to do it, you can't do it. So we actually are really trying to turn embedded software developers into processor designers and verification engineers all in one fell swoop. It's really a cool next step.
I absolutely love the multidisciplinary approach that you're taking, but just to pivot topics for a second, talk to me about Cherry and the Cherry Alliance work that you're doing.
Yeah, so Cherry is a hardware technique to solve a software problem. So for 75 years, the software industry, so in punch cards, from then on, they've classically had a problem with memory safety. And that's because most of the languages out there are not inherently memory safe. So they have ways in which people make mistakes, or nefarious players can create mistakes that create what's called common vulnerabilities and exposures, CVEs by the cyber community. So because you have all of these problems in software, and the software hasn't been able to fix it really well in 75 years, kind of us hardware people have now just said, well, maybe we can solve it. And what Cherry does is it adds instructions, again, the brilliance of RISC-V being able to do that, And it's very invasive in the design, but it adds what's called a capability, which is a 1960s security word for a set of properties on all of the pointers, so you cannot have that problem. So it's a way of defeating the attack surface, which is for about 70 to 80% of the known types of problems that get hacked. And so the Cherry Alliance is a group of like-minded people. A lot of it was driven from Cambridge University, where a lot of this technology was invented over the last decade. And a few of us got together and said, we should do this. Very open in the similar way of RISC-V, but we're not ISA dependent. Anybody can join any ISA. So we're looking to standardize it and have working groups. So similar to RISC-V, but with a Cherry specific specification and not an ISA dependent one.
Fantastic. Well, so much great progress. I really love what Codasip is doing, and thank you again.
Thank you. And we love RISC-V International. Thanks.